the speciality of human brain, if we consider it or compare it with other animals, there are other larger animals. For if we consider elephant, it's definitely bigger than us, but we are obviously from the point of view of intelligence, we are in a greater positions compared to elephant. So why and how the human brain is different than other animals' brain, and what are the rules of evolutions in the process?
So the human brain fundamentally differs from animal brain in the structural, functional, and the behavioral output. For example, if we look at the structural, we look at the sense of smell. Olfactory function or bulbs in the human brain are much smaller in comparing to animals. When we look at this from a rule of evolution, the need for actually using that sense to hunt, if you will, or to establish a sensation of balance when faced with fear, over time sort of diminished, but not in animal. Another example that we find in nature is in navigation. Pigeons, for example, are equipped to have the ability to respond to magnetic stimulus. That's very significant and unique feature in our human evolution and in our comparison to our animal brain. Other comparison is when you look at in the learning space, children are endowed with an amazing memory and photographic memory, when it's compared to other human and adults, quality, that selection feature was kind of front-loaded as opposed to coming later in life. Some people retain it and maintains that equilibrium forward, or some people actually have memory issues and they basically go into a basic processing skill. Other things like brain size, the glial cells, and corticogenesis or neurogenesis, the ability to regenerate cells and the speed of that regeneration between us and animals are significantly different. So structurally, we made out of basically a cerebrum, which is the most evolutionary evolved components of the brain structure, and then you have the cerebellum, and then you have the brain stem. In the cerebrum, we have a lot of functionality and specialization and functional purposes that go beyond what used to be known as left and right hemisphere localization. In the animal brain, you have the very basic mammalian brain for the processing of information like stimulus from sense, from the environment and whatnot, but it's not capable of higher functions like language, speech, calculating numbers, things like that. So.
Human brains in certain areas have developed quite a lot. And do you also believe that this process of development is a continuous process, and in the future we can find even more progress into the areas that we have already identified?
Absolutely. The brain knowledge have evolved to a corpora that is substantial, yet is still a fraction of what we should know about the brain.
Okay.
And it dates all the way to Aristotle, Herophilus, and the old Roman and Greek time. So it's thousands of years of investigation, and it was thought actually originally understood by learning dissection. So dissection is the oldest method for us to kind of have gone into the brain and trying to understand it. And over time, you added technologies like imageries, you got PET scan, MRI, fMRI, EEG, etc. So there's still a corpora of knowledge that has not been yet discovered, and areas that we don't quite understand how it really works. we guesstimate that work, but we don't really know.
Okay. Thank you, Professor Newton Howard. I will very briefly try to translate what you have said so far in Bengali to communicate with our audience.